Assalamualaikum warahmatullahi wabarakatuh. My name is ALIA binti Din and my number metric is S72374. Now I will give the introduction about the Ullmann reaction. Ullmann reaction was first discovered by a German chemist named Fritz Ullmann in the early 20th century. It is a key method for forming carbon-carbon bonds between two alkyl halides. In simple terms, the Ullmann reaction uses copper powder at high temperature to combine two alkyl halide molecules into one compound. For example, biophenol. The reaction is very useful in various fields, especially in organic chemistry, drug discovery, metal science, and natural product synthesis. However, even today, scientists are still unclear about the full mechanism because it's difficult to isolate the short-lived intermediate compounds involved in the reaction. In addition, thanks to modern tools like STM and NSCAFM, scientists can now directly observe some of these elusive intermediates at the molecular level. Recently, researchers discovered an important intermediate complex with the structure carbon bond to the copper, bond to the bromine, bond to the copper, bond to the carbon on a copper 111 surface. When using nitrogen containing brominated compounds, this leads to the formation of the stable nanorings, which give us new insight into how the reaction progresses to the final carbon bond to the copper, bond to the carbon species. Alright, now I will tell the objectives of this research. First, to investigate the reaction mechanism of the Ullmann coupling of the copper 111 surface using nitrogen doped brominated precursors. Second, to identify and observe the new intermediates of the organometallic that form with the Ullmann reaction at the molecular scale using advanced techniques such as STM and NCAFM. Third, to illustrate the structural evolution of the carbon bond to the copper, bond to the bromine, bond to the copper, and bond to the carbon intermediate, and its transformation into the carbon bond to the copper and bond to the carbon species during the thermal annealing.
My name is NAJIHAH binti Zuhari, metric number S72435, and I will present about experimental observation and reaction mechanism. For the experimental observation, researchers studied how the BPBR molecules react on a copper surface. At room temperature, the molecules form nanorings held together by a never-before-seen carbon-copper-bromine-copper-carbon bond. This structure stays stable, but when heated, it gradually transforms. By 333 Kelvin, it started forming the usual carbon-copper-carbon bonds known in Ullmann coupling, and by 353 Kelvin, the transformation was mostly complete. These changes were confirmed with imaging and spectroscopy. For the reaction mechanism, this new intermediate helps explain a missing step in Ullmann coupling. DFT calculations show that the carbon-copper-bromine-copper-carbon bond transformed to carbon-copper-carbon through an exothermic two-step process with manageable energy barriers. Unlike previous model, copper here stays in a +1 to +2 state, making this mechanism more realistic and potentially relevant to similar reaction with nickel or palladium.
So my name is Aina binti Wahabi, number metric S72469. So today I will explain about discussion part. This study focused on the Ullmann coupling reaction on DPPBr on a Cu3 surface under high vacuum, forming a carbon-copper-bromine-copper-carbon chain intermediate. STN and NCAFM imaging confirmed the formation of 6 membrane nanoring, while SRPES and DFT validated the electronic and bonding structure. Upon heating to 333 to 353 Kelvin, the intermediate transformed into carbon-copper-carbon chain bond. Factors including such as molecular geometry, steric effect, electronic interaction, and nitrogen atom influence the reaction process. So the carbon-copper-bromine-copper-carbon chain intermediate acts as a precursor for carbon-copper-carbon bond formation, providing a model for a surface catalyzed Ullmann reaction. So in the conclusion, the Ullmann reaction of DPPBr on Cu3 surface form a carbon-copper-bromine-copper-carbon chain intermediate that transforms stable carbon-copper-carbon when it was heated. This shows how temperature and surface interaction affect the surface coupling.